determine your chances of getting something that you want out of a total number of things that could happen. So like if I wanted to roll an even number on a die, there's 3 even numbers on the die. So I have 3 chances of getting what I want out of 6 total things that could appear on a die. And then you just reduce, and then you get your probability. So this is just real basic probability. So I just wanted to cover a few of these, and then we'll go back and we'll talk about geometric probability. Okay, so this example. It says a bowl contains 12 slips of paper, each with a different name of the month. Find the theoretical probability that a slip selected at random from the bowl has a name of a month that starts with the letter J. Okay, so how many months do we have that start with the letter J?
3.
3. What are they?
January, June, July.
January, June, and July. So we have 3 chances of getting what we want out of how many total things? 12. What's that reduced to be? 1/4. And you could give me 0.25 if you wanted. So you have about a 25% chance of that happening. Okay, next one says, suppose you write the names of the days of the week on identical pieces of paper. Find the theoretical probability of picking a piece of paper at random that has the name of a day that starts with the letter T.
2 out of 7.
Yeah, your probability is 2 out of 7. There's 2 days of the week that start with the letter T. We've got Tuesday and we've got Thursday. And so a lot of times I'll just leave my answer like that, but sometimes I will convert it to a decimal. It just depends. Okay, let's look at a spinner real quick. So I've got 1 through 12. Let me shrink this just a little bit. I've got 1 through 12 on my spinner. What's my chance of spinning a 7? 1 out of 12. Good. What about a 5 or a 6?
2 out of 12.
2 out of 12. You have 1 chance of getting a 5, 1 chance of getting a 6, or means you add. So I have 2 chances out of 12, which reduces to what? 1 chance out of 6. Okay, what are your chances of getting an odd number? 6 out of 12, which is 1/2. So you have a 50% chance. What's the probability of spinning a 13? 0. It can't possibly happen. There's no way, because there's not a 13 on there, so that's not going to happen. Okay, a probability of spinning a multiple of 3. What are your multiples of 3? 3, 6, 9, 12. So how many chances? 4 out of 12, which reduces to what? 1/3. So you have about a 33% chance. Okay, on the next one, try A, B, and C, and then I'll call on some people. Yes, with some sticks.
Is the red one ours?
Yeah, the red one. And you can give me your answers as fractions. That's fine.
There's 14.
5 hippos, 2 lions, 3 zebras, 4 elephants. 5.
14.
Well, hello, Marco. Thank you. Hey, did you do my 18 through 21? Marco, did you do my 8? You did. If you can bring that up to me and show me, please. Okay, Cooper's drawn 6. Cooper, go.
Austin Mason.
Austin Mason, what's the probability of drawing a hippo?
5. 14.
5 out of 14. Beautiful. Okay, another stick.
Christian.
Christian, probability of not drawing an elephant.
5 out of 7.
5 out of 7. It started out 10 out of 14, which does reduce to 5 out of 7. Beautiful. Okay, one more stick, Cooper.
Gavin.
Who'd you say?
Gavin.
Gavin. What was the answer like before you reduced it? Yeah. So the elephants, we've got 4 elephants, we've got 2 lions, you add them up, so 6 out of 14, and that reduces to 3 out of 7. Okay, that was just a revisit to basic probability. You feel okay with that? Okay, let's flip the page. I want to go down to the very bottom, and then I'm going to work back up. So this is different than what we just did. Okay, this section down here, it says, find the probability that a point chosen randomly inside the rectangle is in each shape, round to the nearest hundredth. This is like, pretend this was my dartboard here. If I wanted to know, if I threw a dart, what's the probability of my dart landing in the triangle? Can everybody listen, please? So pretend this is a dartboard, or it's full with balloons, whatever, and you're throwing a dart. I want to land in the triangle. So does it make sense to you? The probability of landing in this triangle could be anywhere in here, out of anywhere in there.
Yeah.
Okay, so I need to find the area of this, because my dart could go anywhere in the area of this triangle, and find the area of the whole thing, because my dart could go there. So my probability will be the area of this shape out of the area of the whole thing. Does that make sense?
Yeah.
Sure? Okay, so my probability, this is my game plan. I'm going to find the area of the triangle out of the area of whole shape. So that's how I'm going to find my probability. I'm going to find the area of the triangle, because that's where I want my dart to go, out of the area of the whole shape. So let me just come down here and find the area of the whole shape. What shape is this whole shape?
A rectangle.
A rectangle. How do you find area of a rectangle? Length times width. So I'm going to take my 24 times my 48, and what does that make? 1152. Okay, so that's the area of the whole shape, 1152. Now I need to find the area of my triangle. How do we find area of a triangle? Half base times height. So I know that this is the height because it's straight up and down, and I know the base is always attached to it. So if I take half of base times height, what's half of 10 times 10? 50. Okay, and then this does say round to the nearest hundredth. So put that in your calculator, and let's round it to the nearest hundredth. Yeah, I picked up all the calculators yesterday after school, so. Sure. Draw me a stick. Okay, Zach, what do you get if you round to the nearest hundredths?
You get skill. How'd you know it?
0.04. So we have about a 4% chance of our dart landing in that triangle. Okay, so that's a pretty small chance of our dart landing in that triangle there. Okay, number 2 wants to know what's the probability that if we threw a dart, it would land in the square. So I'm going to do the same thing. The probability will be the area of the square out of the area of the hole. So area of the square out of area of the hole. I already know the area of the whole thing, right?
Yes.
What did we say the area of the whole thing was? 1152. Now I just need to find the area of the square. 100. It's just base times height, their length times width, and 10 times 10 is 100. Okay, go ahead and divide that, and let's round that to the nearest tenth, and Cooper will draw another stick, because it's fun. Go for it.
Craig.
Craig! 0.09. Okay, so this is geometric probability because you have a chance of the dart going all kinds of places within that rectangle, and so you have to find the area of something out of the area of something else, the grand total. So that's why it's called geometric probability. Okay, this section up above, this is more of a pain, but the goal is the same. So if I want to find, pretend it's just a dartboard again. If I want to find the probability of my dart landing in this red section, it could land anywhere in this red section out of anywhere in the circle, right? So I'm going to do it just like I did a minute ago. I'm going to find the area of my red section, because that's where I want my dart to land, and I'm going to take it out of the area of the whole thing, which is a circle. So that's my game plan. Probability will be the area of the red out of the area of the whole, and I'm just going to put the whole, but meaning the whole circle. Okay, so how do we find area of a circle? Pi r squared. So if I take pi times my radius squared, what's my radius squared here? 36 pi, because it's pi times 6 squared, and so the area of the whole circle is 36 pi. Okay, so that's going to be my denominator. Now I need to find the area of the red. So I'm just going, well, I'll just color it in red. If I wanted to find the area of that guy, does that look like something we've been doing lately?
Yeah. You add them up and divide by 306, right? Are we doing it like that?
It's 80 over 360 and then x over whatever it is.
Right. I'm going to set up that little proportion. If I want to find the, I couldn't tell. If I was trying to find the area of this sector here, I take how many degrees the arc is, which is 80 out of 360. And then I want to know its area out of the area of the circle. And we already figured that out. What's the area of the circle? 36 pi. Okay, take a second, cross multiply and divide just that part right there, and let's see what you get.
Is it in terms of pi?
Yeah, let's leave it in terms of pi.
Okay. Yeah, it's 8 pi.
Boop, boop, boop. Okay, is everybody getting 8 pi? Okay. And then let's just go ahead and make this to the nearest hundredths too. So take a moment and tell me what your answer is to the nearest hundredths. And I'll have Cooper draw a stick.
We could do that.
We could.
Just for fun.
We could.
What we shouldn't, Greg.
Hey, we need to go over it. There's an easy way to do that. Check it out.
But technically, this is how it should be done because that's how you do geometric probability. I understand you could in this problem, but in this problem there isn't an easier way. So I'm trying to teach how you can do all of them using the same method. Okay, stick time, Cooper. Who do you get?
Autumn Parker.
Autumn Parker.
Probably didn't get this right, but I got 2.1.
No. Did you put 8 pi divided by 36 pi in your calculator? Oh, I know the problem, and I'm glad that this happened. I need, if I'm going to put it in my calculator like this, I need to put parentheses around that 36 pi. 8 pi divided by parentheses 36 pi. I'm really glad that that happened because I needed to talk about that again. Whenever you have more than one thing in the denominator, you do need to put parentheses around it, and you should get 0.22.
But you also can cancel out.
Yes, I know. And that's how I did it when I did mine. So we have about a 22% chance of our dart landing in the red section. Okay, let's look at 2. 2 says the pointer landing on purple or blue. So I'm going to do the same thing. I'm going to find the probability of the area of purple or blue, and then I'm going to divide by the area of the whole thing. Okay, so let's start with the area of the whole thing. We already know that. What's the area of the whole thing? 36 pi. Okay, so now I need to find the area of the purple and the area of the blue and do what with those guys? Add them together. Okay, so we'll just skip number 3 and we can just do our proportions down here. So let's do purple first and then we'll do blue next. Okay, so purple. How many degrees is the purple arc?
75.
So it's 75 over 360, and the other side would be x over 36 pi. Okay, let's get that answer. Cross multiply divide, and we can go ahead and keep this answer in terms of pi here. Yeah, sure. Draw me a stick. Who'd you get? Alex? Alex! What's your answer in terms of pi for this proportion right here? Should be 7.5. You must have messed up somewhere. Okay, so that makes 7.5 pi. I'm going to go ahead and put that up here, 7.5 pi. Okay, everybody take a second and find the blue. This one? Yes. Okay. And what's your office number? Because I don't know if he knows. Oh, he'll know. Okay. All right. Can I? Do you want him right now, or can I wait about 10 minutes? Okay. Thank you. Bye. It's so funny how you guys are just like, who was that for? Do we have the blue? Okay, Cooper, draw me a stick. I want to hear the proportion.
Austin T.
Austin T. Give me the proportion for the blue. Here's the blue. No, just the proportion, hun.
Oh, 60 over 360.
60 over 360, and the other side? X over 36 pi. Can someone tell me the answer that they got for that? Just out loud, anybody? 6 pi. Okay, so up here, I need to add that to the 7.5 pi, because I want the probability of landing on purple or blue. So I have to add the purple to the blue, and then I divide by the area of the total. Okay, everybody take a second and see if you can calculate this to the nearest hundredths. And I'll have Cooper draw another stick.
I'm not cheating. I did that for pulling your name. That was once. It wasn't even for the thing. I just randomly following things up.
Okay, give me a stick.
Marco.
Marco! What do you get when you calculate this?
1.17?
No.
Wait, give me a second.
And if you're going to put those pies in your calculator, you'll need to put parentheses around your whole denominator here if you put the pi in.
Oh my God.
You have a problem over here? Oh, thank you.
It's because I keep losing the back and the batteries.
0.
What'd you say?
3.70.
Your decimal's off a little bit. Okay, so I put 7.5 pi plus 6 pi in my calculator. I'm not saying you how to do it like this. And then I'm dividing by parentheses 36 pi, and you should get 0.38 if you round to the nearest hundredths.
Yeah, I didn't put it in parentheses.
What?
I put mine together.
The numerator? Yeah. That's not a problem. Okay, let's flip and look at some dartboards that actually kind of look like dartboards. Okay. This one is worked out. I just want to walk you through it. It wants to know the probability of getting at least 10 points. Can everybody please focus and stop your conversations? What does it mean to get at least 10 points?
Circle around the table.
Yeah, but like, what's that mean?
10 or more.
10 or more. So if I want to get my dart to land where I get at least 10 points, I want 10 or more points. So I want my dart to land anywhere in here, right? Okay, so it's going to be like before. If I want my dart to land in this section right here, I need to find the area of this section out of the area of the whole thing. So that's what this is saying. The area of this section right here out of the area of the whole thing. So if I wanted to know the area of this section here, I would need to know the radius, because remember, area of a circle is pi r squared. So it tells you up here, no, I guess it's just a picture, that this is 2 inches and that the width of each ring is 2 inches. So if this is 2 inches, this would be 2 inches, and so that radius is 4. So that's why you see that. And so if I want to know the area of the whole circle, this is 2, this is 2, this is 2, this is 2. So what's the radius of the whole thing? 8, which is why you see that, and then you see it worked out. Okay, so let's try the probability of scoring 20 points. So if I want to score 20 points, my dart can only land right in here, right? If that's what I want is to score 20 points. So I'm going to find the probability by finding the area of the, I'm just going to put the 20 out of the area of the whole thing. Okay, so here we go. The area of the 20. What is the radius to this little circle that has the 20 in it? 2. The radius is 2. So the area would be pi times 2 squared out of, okay, what do we say the radius of the whole circle is? It says width of each ring is 2 inches, 8. So pi times 8 squared. Okay, see if you can calculate that.
Greg, I got 3 calculators on my desk. I think I can find one.
Do you need a calculator? You don't need a calculator?
And let's just go ahead and round to the nearest hundredths like we were doing a minute ago. Yeah, stick. Why not?
Emily Gray.
Emily Gray.
Death threat. Okay, I want to show you something real quick if you didn't want to have to do all of this in your calculator. What's 2 squared? So 4 pi. What's 8 squared? So 64 pi. Do you agree that this pi in the numerator and this pi in the denominator can cancel? Shoop. All you have to do is put 4 divided by 64 in your calculator, and what do you get? 0.06 if you round to the nearest hundreds. So you have about a 6% chance of your dart landing in the 20. Okay, number 2. I want to score 5 points. Exactly, that's my goal. So let's talk about that. If I want to score 5 points, I want my dart to land in this ring right here. Does that make sense to you? Do you know how I could figure out the area of just this ring? Austin, Mason, I'm going to ask you. How could I figure out the area of just this 5 ring? Because that's what I want to do, is score 5 points. How could I find the area of just that little ring there? Do you say things that's
Austin. Well, I asked you.
Oh, I'm sorry.
How could I find the area of this ring with the 5 in it?
Well, it's going to be the radius of whatever this point is. So if you're going by the entire radius, then you go to the entire radius until you get the radius of that and subtract it.
Oh my gosh.
Okay, so tell me again.
So like get the radius of the entire circle and the radius of 5. Then you subtract the radius of the entire circle.
Are you talking this entire circle?
Yes.
Okay, too much. Let me draw you a picture. If I want to score 5 points, if I found the area of all of this, can everybody focus? Because you've got a problem like this on your test on Friday. If I found the area of all of this, and I just want to score in the 5, is that too much area? So I would need to take away. Would I need to take away these 2 inside circles?
Yes.
So let's do that. So my probability is going to be me finding all of this and taking away from it out of the area of the whole thing. Okay, so let's find the radius of all of this. What is the radius from here to here?
6, 8.
2, 4, 6. So the area of this circle right here is 6. So that's going to be pi times 6 squared. But you said that was too much area, right? So I need to subtract, and I need to subtract these 2 in here. So what's the radius of that?
You get 3.5.
4. So minus pi times 4 squared. And then out of the area of the whole circle, because my dart could land anywhere in that entire circle, what's the area of the whole circle again?
8 pi.
64 pi.
64 pi. Okay, take a moment, see if you can calculate it. And we'll have Cooper draw a stick. Go ahead and round to the nearest hundredths. And I don't care how much or how little you put in your calculator. I just want to see if you can get it rounded to the nearest hundredths. What?
Wait, can you do it to where you do the math and then you add
Oh,
pi
sure.
after?
Yeah.
Yeah.
Are you ready to split?
Almost. Okay, Cooper, go ahead. Tristan, what do you get? Well, you can help me out. How much is 6 squared? So 36 pi minus how much is 4 squared? So 16 pi, and then I'm going to divide that by the whole area, 64 pi. So let's just keep using our heads here. What do you think 36 pi minus 16 pi is?
25.
In terms of pi? 20 pi, and then I'm going to divide by my whole area, 64 pi. Those pi's can cancel out, and then all I have to do is figure out what 20 divided by 64 is. Can somebody tell me?
0.31.
Okay, so 0.31 if we round to the nearest hundredths. So we have about a 31% chance of our dart landing in just that 5 ring. Okay, I imagine we'll need to practice a few of these tomorrow. So I'm going to give you a little assignment. Let's see here. I want you to try, this is page 25. It's just the next page. On page 25, I want you to try 12 and 13. And then on the back, I want you to do 16. And then I want you to try the 18, 19, and 20. I want to see what you can do with the dartboard on your own.
Wait, what page was the homework on?
So it's page 25, it's 12 and 13, and then 16, 18, 19, and 20. And we can talk about those tomorrow.
What page was last night's homework on?
Oh, last night's was, yeah, right
This
there.
one? These are the problems?
Yeah. Yeah, that's it. Okay. Hey, I know.
I see it.
That's great. So in the picture. Super. That's a great video. Thank you. Okay,
How are you, my dear? Good. So Sydney told me that you curled your hair for a full.
No.
That's what she told me. It's okay.
No, I curled it for fun on Monday, and then I was Snapchatting her, and she's like, "Oh, curl your hair for tomorrow," and I was like, "Okay," and then she was like, "It's true." I said, "No." Yeah.